This is question 45 of Civil Engineering paper GATE 2015 afternoon session. The average surface area of a reservoir in the month of June is 20 km square. In the same month, the average rate of inflow is 10 meter cube per second. Outflow rate is 15 meter cube per second. Monthly rainfall is 10 centimeter. Monthly seepage loss is 1.8 centimeter and the storage changes 16 million meter cube. The evaporation in that month is. So, in this question, for a reservoir, the average surface area in the month of June is given as 20 km square. And in that month, the average rate of inflow, the outflow rate, the monthly rainfall, the monthly seepage loss and the storage changes are given. Now, we need to find the evaporation. So, this question is from the topic of basic conservation laws of water budget equation. So, you may study about conservation laws and water budget equation in detail by watching lecture 6 Conservation Laws Engineering Hydrology by Dr. Srija Pekat, IIT Guwahati. So, we know from the water budget equation inflow minus outflow is equal to the change in storage. So, first we find the inflow, total inflow, and then we may find the total outflow and the storage is given. So, by putting all the component in this equation, we can get the evaporation. So, in the hydrologic cycle, few components are considered as inflow and few components are considered as outflow. So, the basic things it can be observed for this reservoir, what are the components or what are the ways in which water is coming to that reservoirs. So, we can say the inflow is directly written here. So, rate of inflow, it is coming to the reservoir, the water is coming to this reservoir. The rainfall is also coming to this reservoir. So, this can be considered as inflow. And for outflow, so outflow rate, it is already written outflow. So, obviously, this will be outflow. Seepage loss, it means the water is going out from that reservoir. So, this is also considered as outflow. And the evaporation, so in evaporation, water also goes out from the reservoir. So, this is also considered as outflow. So, by this considering these things, we can find this evaporation. So, first find the total inflow. Now, also observe here, few components are given in terms of volume and few components are given in terms of depth. And we need to answer in terms of depth. So, it is better to convert all the units in terms of depth only. So, the rate of inflow is given as 10 meter cube per second. So, 10 meter cube per second. So, first convert it into the centimeter cube. So, centimeter cube, for that just multiply it by 10 to the power 6. So, this is centimeter cube per second. Now, the total volume can be found by multiplying it by total time. So, for the month, for 1 month, so we can write this second into minutes, into hour, into total hour, into total days in a month. So, in June month, there are 30 days. So, this is total volume. So, now if we divide the volume with the area, we can find the depth. So, area is 20 kilometer square. So, for 20 kilometer square, we can write 20 into 10 to the power 10. Now, it is in centimeter square. So, this is inflow. The rate of inflow plus also one more component is rainfall, which is 10 centimeter. So, when we solve this, we will get this as 129.6 plus 10, which is 139.6 centimeter. So, this is inflow. Now, outflow. So, outflow is given 15 meter cube per second. So, again just convert it into the depth. So, 15 into 10 to the power 6. Now, it is in centimeter cube per second. So it multiplied by total time, which is 60 into 60 into 24 into 30. So this is total volume, just divide it by total area, which is 20 into 10 to the power 10 centimeter square. So this is outflow rate plus this seepage loss. So plus 1.8 plus evaporation. So let evaporation E is occurring. So this is total outflow. So if we solve this, so this will be 194.4 plus 1.8 plus E. So this is 196.2 plus E. So from here we can observe the value of inflow as 139.6 and outflow as 196.2 plus E. Since there will be some evaporation, so this will be some positive integer. So this value is obviously greater than 196.2. So from inflow and outflow value, we can see here for this reservoir outflow is greater than inflow, and in case of if outflow is greater than inflow, we can say there is a depression in water level, depression or fall in water level. So the changes will be in negative, the storage change of that reservoir will be in negative. So we know the water, just apply the water budget equation, inflow minus outflow is equal to the change in storage. So here inflow, we got the inflow as 139.6. So this is 139.6 minus outflow, which is 196.2 plus E, minus 196.2 plus E. And since there is a depression in water level, so we can write the storage changes in negative. So this is minus 16 million meter cube. Again, this is given in this volume, so convert it into depth. So 16 million, so 16 into 10 to the power 6 into meter cube. So meter cube, so it will be 10 to the power 6 centimeter cube by total area, which is 20 kilometer square. So 20 into 10 to the power 10 centimeter square. So when we solve this, we will get E, the value of evaporation as evaporation value we will get as 23.4 centimeter. 23.4 centimeter. So we got the evaporation for this reservoir as 23.4 centimeter. So 23.4 is given in option D. So option D is the correct answer for this question. Thank you.